So we're going to look at a couple of inverse trig functions. The first one I want to talk about deals with sine. So I start by graphing regular sine. So f of x equals sine x is graphed here. I have just a few points labeled. And then I need to recall that when I'm finding inverse functions, I need the function I'm looking at to be one-to-one. And one-to-one means that it passes the horizontal line test. That not only for every x we get one y, vertical line test, but every y goes to one x. So I need to take a chunk of x values such that my y values are one-to-one. So the conventional chunk that we take is between x equals negative pi halves and x equals positive pi halves. And remember what our range is for sine x, right? Those values go between -1 and +1. So all of that information, my domain restrictions. So before I go finding my inverse function, I have this domain restriction. So the domain I'll be interested in goes from negative pi halves to pi halves. The range of my original function goes from -1 to 1. And really, in order to find the inverse sine, it's just learning the new notation. Okay? So inverse sine, there are two different ways we can write that. One of them is with the -1 in its exponent position, where we put that for trig functions. So I'll call it g of x so that we don't get too confused. So for inverse sine, we just put a little -1, right, our notation for inverse, and it goes between the trig function and its argument. You might also hear another name for this is arc sine, and you just run those two together. So these are synonymous, arc sine and inverse sine. So why did I have to do this one-to-one, and why was that such a big deal? Well, the reason is that when I come down here and talk about, right, doing my inverse trig functions, remember when you do the inverse function, the domain and range trade places. So for g of x, its domain, what we're allowed to plug in, is the range from the original. So we can take the arc sine of any number between -1 and 1. Here's the important part. But the values that we get out can only be between negative pi halves and pi halves. That's this one-to-one. Here's where this comes into play. Okay, so let's go ahead and practice finding some inverse trig functions. And as we do, I want to talk about kind of what we're finding, what it means. So here we go. So I want to find the value of the inverse sine of 1/2. So inverse trig functions, their output is the angle. So this is my ratio, and I want to know what angle, right, leads to a sine of 1/2. So really that unit circle can be so helpful because I need my sine values or my y values, and I need that to be 1/2. So I need the y value here on my unit circle to be 1/2. Well, what angle leads to that? Keeping in mind, I need to pick a value between negative pi halves and pi halves, because right, there are a lot of different values that would have a sine of 1/2 or a sine equal to 1/2, but I want the one that goes between negative pi halves and positive pi halves. So that one is pi sixths. So when you're finding the inverse trig function, right, its value is the angle. So the argument is the ratio, the answer is the angle. All right, what's the inverse sine of 0? So what angle leads to a sine of 0? So I need the y value to be 0. That happens when your rotation is 0 as well. And just to see the other notation, so arc sine of 1 over root 2. So where does that value happen? On your unit circle? Exactly. Pi fourths. As well as a bunch of other places, but pi fourths is the only one in that, the allowable interval. And sure, 45 degrees is fine as well. So that's inverse sine. Let's take a quick look at inverse cosine, figure out how we would partition it so that it's 1-to-1. So I'm going to put a quick little graph right up here for my cosine. And I always have to start up there at the top point and then just do my long hair. And let's see, cosine starts high. The first time we're at 0 is when we get up to pi halves. And this might be pi, and then this would be negative pi halves and negative pi. And I need a chunk that is 1-to-1, that horizontal line test. So you might take, right, I could take that chunk right there between negative pi and 0, but then I'm dealing with negative, right, negative angles. I don't want that if I don't have to, and I don't have to because I could just as easily take this little partition. Okay, so when I do my domain restriction on cosine, I need the domain of y to only be between 0 and pi. So this is the interval we can choose from when evaluating inverse cosines. And for inverse tangent, remember tangent has those asymptotes. Looks kind of like, but isn't, an x cubed repeating. Remember, tangent has that period of pi. And so the easiest one that we take is between negative pi halves and positive pi halves. So the domain of this one, where we will find our answers for inverse tangent questions, will be between negative pi halves and positive pi halves. Okay, let's see. So inverse cosine of 1. I'm going to draw, again, a little unit circle right here so that I can find those angles. I need to find an angle such that the cosine is 1. Remember, cosine are your x values. So as I go around my unit circle, the x value is 1 over here. I need to pick a number between 0 and pi, and 0 is the only value between 0 and pi on my unit circle, right as I rotate around, that has an x value of 1. So 0, right, this is the angle that leads to a cosine of 1. Cosine of 0 is 1. Okay. What about negative root 3 over 2? So remember, I'm on this chunk right here. These are the x values, right? These are the angles I'm interested in so that my cosine is 1 to 1 between 0 and pi. So I need to find the rotation that leads to a cosine, an x value of negative root 3 over 2. So my x values are negative over on this chunk here between pi halves and pi. And which one leads to that negative root 3 over 2 for an x? So that's my big X. That's the pi sixths one, 6 pi sixths, 5 pi sixths. Okay. That's the one x value between 0 and pi that has the cosine equal to negative root 3 over 2. Okay, inverse tangent of negative 1. So for inverse tangent, right, this time I can pick pick values between negative pi halves and positive pi halves, and I want to find the angle in there where the tangent is negative 1. So tangents are positive here and negative here, so I'm down in this chunk between negative pi halves and 0, and it's 1 when sine and cosine equal each other, which is that pi fourths, but I'm down, so negative pi fourths. And inverse tangent of 1 over root 3, so this one is positive, so I'm going to be in this upper chunk, 0 to pi halves, and 1 over root 3 corresponds to 30 degrees.